G'day guys, I have a GP-Extreme. This is a GP-Extreme, it's written on it, and this probably also goes for the GP-3000 as well. Some of them, not all of them, but some of them. Now I've got the video set up like this because I should point this out because I know some of you fellows still have these. Actually, the GP Extreme in a way is probably the best detector that you can get your hands on for big deep gold with a big coil, right? This detector is very sensitive. The filtering in the later model, which is the 3000, is a little bit heavier, and I think it does actually impinge a little bit on the depth capability. But I've always found the GP-3000 to be exceptional. The only thing is you don't have the other modes. You have normal mode and derivatives of normal mode, and like the sensitive and so forth. Yes, it does make it more sensitive, but then you'll lose depth in using sensitive mode. So the way you would use one of these is, you can see here on the switches, you would put it into normal. It's very confusing. I've got to remember this. Enhanced, E means enhanced on this model. Now the terminology has changed for the years, and this is why it gets really confusing, right? Normal is on this is a double D coil, right? Okay, so normal is a double D coil. E for enhanced, that one there in the middle, right, is for a mono. Right? And cancel is the same. It's still cancel. It does make me laugh because it's so confusing. Imagine using this detector and having all this knowing the terminology, and then a couple of models later, it's all different and it means different things. But anyway, okay, it has salt mode, it has the sensitive mode, and N is normal. End normal mode. That's how you operate this thing if you're looking for big deep gold. So you got N, E, right? And you can put it in fixed or tracking depending on what you like to do. If you're going to use a big drag coil or a 25-inch, 20-inch coil, then leave it in fixed, but ground balance every so often. Throw it back into tracking, make sure it, just drag it for a bit, make sure it behaves, put it back in fixed. It shouldn't make any damn difference. If you're dragging the coil very slowly, a very big coil very slowly, on an intermediate size target coming up on it slow, it may partially track out, depending. If you're looking for meteorites, it may partially track out. You're probably better off leaving it in fixed and running an extension wire onto the connectors here, which some people do, and there we go, put it back under there. On the switches, run an extra couple of wires and just make and break it every so often. If you have a look at the way it's done, when it's in tracking, the switch, these two wires to that switch are shorted. So shorting those together is tracking. Open circuit is in fixed. So you can have an extent, leave it in fixed so it's open, and just run a push button switch somewhere else, whatever, and on the handle maybe. It's probably a good idea. And just push it and it will track and then let go back into fixed. So you can use a later button, say on one of the 3500s or something like that. But you know, it depends what you're looking for. Normally, you know, if you're coming up hard and fast on a target, it's not going to track out. Once it detects it's there, you know, it's not going to start diminishing the signal by any margin. But you know, on really iffy targets that are hard to hear, leave it in fixed. Just leave it in fixed mode or fixed tracking, not mode tracking. So yeah, looking for big deep gold. E is for mono, right? And N is normal. Always detect in all metal. You know, for mono, it's not going to discriminate anyway, so that's how you'd run this. But anyway, we'll get on to the nitty gritty of this. I'll zoom in a bit. I'm standing up here. Well, there we go. I don't want to lose the interesting bits. And I've got to find some bits to show as a comparison on some of the things I'm going to go on about. Let me have a look, see here. Okay. I'll get some of these. Now I'm going to pop one out. I've got some input stage devices here. I'm going to pop one out. Remember all the stuff you read about being all these Mosfets being static sensitive and you touch it, it'll blow up. I'm going to show you something, right? In these are meant to be you know, conductive. The plastic's conductive, so it's trapped in there. It can't really build up a charge or anything. But when you do Mosfets, the simplest way to handle a Mosfet rather than panicking and having grounding straps and all the rest of it is touch it to your hand like so. Just tip it onto your hand. It can't build up any charge. There's no charge. It's same potential everywhere. Even if you want to get really critical, touch one hand to the other hand, right? Then touch that. It can't build up any charge. Everything's the same potential. Then grab your device, and what I would do here, touch your board. Put your fingers on your board, touch it. You are now at the same potential as the board. The device is in your fingers. It's all at the same potential. Put it on a board. All right? Where it blows these things up, and these have protection diodes anyway, so they're not going to blow up, but the old stuff did. But if you want to be really careful on a really cold, crisp day, you can generate enough charge if you're touching it and then take it to something of a different potential, like so, and it sparks. You can't see it, you won't hear it, but you can get thousands of volts, and it can puncture the diodes, and it can also puncture the drain source if you're very unlucky. It's one of those things that, you know, you should all be earthed and everything should be same potential, but if you're touching everything when it's all at the same potential, it's not going to make any damn difference. I can tell you that because I've done hundreds and hundreds of Mosfets and they don't blow up. So, okay. On this device, on this detector, this GP-Extreme, and also on some of the GP3000s, depending where in the cycle of manufacture it was, these two transistors here, or Mosfets, right? I sometimes I call Mosfets transistors because they damn well are actually. They are transistors, but they are a Mosfet. They're not a silicon. So these ones here, I don't know if you can tell the size of this one to this one. And there's two of them actually, because we got the cancel mode. You need two to run cancel. For double D, it uses that one, and that one it's basically ignored out of circuit. It's still switching and everything, but it's ignored in the circuit via the 405, is it 4053 or 4051, one or the other. Anyway, it gets ignored. So in DD mode, it's only using that one, but when you go to mono mode, it uses both. It parallels both of these through the multiplexer, and they're just combined. So on these older detectors, these MOSFETs, I'll use the right terminology, these MOSFETs, now, I'm trying to remember the number. I haven't touched these for a long time. I don't scrape the paint off and try and work out the numbers on these. But I do know I haven't looked for a long time. I wouldn't have any. They're very old and they're slugs. But I'll just have a look, see if I can remember the number. What are you things? No, they're not that. I thought they might have been IRF 214s, but they're not that. I absolutely have a mental blank on it, on what they are. I'm trying to think back to the last time I ever touched them, so long ago. It'll come to me. I'll think about it and I'll go, oh, that's what it is. But anyway, whatever these things are, these bigger, chunkier looking devices are a bit of a high capacitance, higher resistance slug, right? Well, they're higher capacitance on the gate. They're harder to switch. They're very, if you want to switch it really fast, it doesn't switch as fast as one of these. Now, this one here, the little tiny one, that's what's in all the new modern detectors, okay? But these are out of production now, so you can't get them. So it's a 2SK1334, all right? And this has a lower on resistance, lower capacitance. It's got all the attributes about it are much better than these things. So what we do, very carefully, heat these up. You can use hot air, but just don't burn everything around it, or scrape the paint off this bit here. It's a bit of metal under there, and it's 3 legs. And remember, they're stuck down with glue as well, so be careful if you heat it, it won't come off, and then you pull it, because it'll pull the pads off, because it'll come away very quickly and you won't have any control. So just best to heat it up and just tap it until it starts moving. You've got to get it pretty hot to break the glue bond underneath. The solder would have melted, but it's the glue bond. But if the solder doesn't melt for some reason, if for some reason it's re-solidified, when you go to push it off, it'll pull the pad off, and it's quite painful. So we don't want to do that. Now, this is a factory one, by the way. It's never been touched. And this has very thick white paint on it, or epoxy. And there's an extra little wire here, a little ground wire they've put in. This was done in production. I think something happened. It was taking something out, and maybe it was puncturing one of these MOSFETs here. I cannot remember the whole scenario about it, but these detectors started turning up when we were doing GPs with this wire, and it's also on the GPs as well. Earlier ones of these did not have this wire. It goes to the ground connection of a capacitor here and connects up to one of these input diodes. Yeah, nothing really to worry about. You can, if you want, you can put it in, but it's buried under here. I think it goes on this side here. But like I say, it's buried under a whole heap of glue and white paint over it. So I'd have to scrape all that away to see where it is. Like I say, I haven't done one of these particular detectors around this area here for a long time. It is rare for me to see these devices still in the detectors, but they're old slugs. So what I will do on this one is take these out, and I'll put 2 of these 2SK1334s in the place of these. The other thing on this as well, I think, remember I was saying about the MOSFETs, you touch it, touch your board, touch your device, pick it up, and I'll stick it back in where it came from. Okay, And there you go. Let's leave it there. There is something else about these detectors, and people should know about it. Now, let's go out of frame for a bit. I hope we're still in focus. I have to stand up. It's telling me low battery, but we're still working, I think. Good. Okay. There is the damping Mosfet around here too. So move across. I've got the tripod on the bench, and the detector's bumping into it, won't move, so bear with me. Okay. Yeah, somewhere around here, there is the, under all this glue here, there's a damping Mosfet. You can change that too for a faster, lower on resistance. Not that it's going to make much difference, but it may. I've never gone and done A and B comparison with this, see if it makes a difference. But I know that if you change these ones, it does make a difference. Okay, now, I'm going to open it very carefully. It's very different to the new detectors. Dear me. Now, the worst thing about this detector, or any of these ones that have been painted with the white paint, hang on a sec, I'm going to move around here a bit. Okay, these strips here, these interconnect strips, that one and that one. Now, these got painted with epoxy paint, and what happens is that the paint sets and makes it want to stay whatever last shape it was, right? So when you open it, this epoxy, because it's very thick, will crack. And if it cracks, it causes a weak spot that if you move the boards open and close, it'll hard bend on where the crack is across there, and it will snap the inner conductors. They're very, very thin. And it's a big problem on these. Look, you know, if I hit that, you can tell how hard it is. That's meant to be flexible. It's a flexible strip. It's hard as a rock. So is that one, right? But move it, it will crack. And this one's already got a crack in it. You've got to be ever so careful not to keep working it on those cracks, else your detector will stop working and you won't know what's going on. Because half the time you go and measure between the pins on these, and whilst you've got the board in a different position, you'll have continuity, and when you move it a bit, you haven't. So it's intermittent, so you just got to be careful. The other thing too on these, which I've already been here and got them out, and catching up on the tripod, get back under there. On this one, here and here, it's a bit yellow around there because I put some resin flux just to help things move, where I removed the two devices here. And the reason why I removed the devices, and I'll show you why. I'll get one. Okay, I've got him sitting in some acetone. I was just going to try and clean it up. But you need to, oh God, can I get my hand under there? There we go. Have a good look at that thing, right? That's the bottom of it. All the numbers are scraped off the top, and it has white epoxy paint over it. But if you look at the bottom of this one, this one here, oops, there we go, is dead flat, right? That is a real AD797. That's a genuine article out of a detector, not out of this one, but I just marked it that way so I know where pin 1 is, which is there. But this one here, you can look on it, it's been laser etched on top, it's been cross hatched. But that's a real AD797. Now what was in this one? Also got this one sitting in the acetone. Get my hand under there. if you can see on this one, see a little circle? That means 99.9% sure it's not an AD797. That's like an NE or LM. What do you want to call them? We don't use them anymore, but yeah, it's a 5534. That's it. It's a dual 5534 NE, LM or something. NE, depends who made them. But if you've got that with the circle on it, I'm trying to get it so it shows good. There we go. You can see that. I don't know what's written on it. Probably manufacturer, some date code or something. But usually find those on the NE 5534s or any of those earlier chips. For some reason, the really good chips don't have any marking on the bottom. So if it's got those circles on it, get rid of them and put in some AD797s. And it's a good improvement to these old detectors. It'll be a lot quieter. It'll be well behaved. So that goes there. Yeah, okay. There's a few other things with this, but do I get into it? It does have manual adjustment here, earth field and balance and subtraction circuits that get rid of the ground. Apart from that, it's got chunky driver Mosfets. You know, all the new ones are, you know, little SOIC 8 leg things. These are big, huge, and these actually blow up, believe it or not. That one there, the little one is on the 15-volt rail for the small pulses, and this big chunky one's on the 5, and the 5 one does blow up. So yeah, it's meant to be rated, I think it's rated at 20 amps or something. It still blows up, even driving, you know, an amp. Probably gets taken out by high voltage coming back where this electrolytic here, that's meant to stabilise the flyback to, you know, 180 volts or whatever. It's probably not fast enough. Transients get through, so you know, you can actually do something about that, which I'll get onto in another video. I've had lots and lots of this style of detector blow the Mosfets out of it. The input Mosfets mainly, and also a lot of them blow this, and a lot of them blow that. That's the MOSFET that acts as a variable resistor, and it is basically monitoring that flyback voltage and stabilizing it with the capacitor. So these things blow up all the time as well. That blows up, that blows up, that blows up, and the input FETs always blow up, and when they blow up, it takes out more devices, takes out the small P channel on this, and yeah, it takes out that little transistor. I don't know if you can see that. You know, pull it over again. Little transistor here, which drives the MOSFETs. I actually got to get down and actually look. Okay, there are our Baker clamp type things there. That's there. It's that one there. Tip of my finger blows that one up. And when you replace it, you have to discharge the capacitors. Don't worry about 200 volt one. Don't touch that anyway. It'll zap you. But where that wire goes is a cap and another cap next to it. The 15 volt rail, you've got to short it out. If you don't, it'll blow up the PNP bipolar, and it'll also blow these up. And when this all goes haywire, it takes out the other P channels, either or both, and can also take out the BF 998s that are there. 998s. I'm using 998s now, but they had BF 908s in there, but no longer available. So that's the story with that. Yeah, we'll keep going back to these old detectors every so often because even though they're old, they're really good. They are really good. They can be made really good. This one actually is going to get fully upgraded. I'm putting new boards in it, putting variable frequency into it. We're putting variable gain into it, and just basically lowering the noise floor. And this is for another project detector for a big, deep gold detector, which is for a customer who has requested it for such. Anyway, that is the GP-Extreme, and the same thing goes for the GP-3000 and more or less the 3500 as well, except the 3500 does have AD797s in it throughout the whole series. It's chopped and changed through the GP run. There's some 3000s I've found that have the noisy NE5534s. So the only way to find out, you've got to remove them, and you've got to be damn careful on that too. The pads are very, very small and very easy to damage, and because there's a lot of little tiny through plates to the other side of the board, and they're under parts and so forth. If you destroy them, it's really, really, really difficult to fix. It's a nightmare. So be careful if you try and take these devices off. You got to make sure it's unsoldered or soldered, unsoldered, whatever. Same meaning. Yeah, but these old detectors, don't throw them in the bin. Don't give up on them. They're really good. See, so many people now. The thing is, you see a lot of gold, very, very small gold, because all the detectors are made for very, very small gold, right? You don't see anyone running huge coils anymore. Used to, and that's when big gold was found. And you know, if you've got everyone looking for small gold, there's gonna be small gold popping up all over the place. But if you had everyone running 20-inch coils and not running in these little fly spec detecting modes, you'd see a lot more big gold. But it's just there. People want to go looking for big gold, still there. And people think, oh, it's all gone. No. All that's. You look at the previous detectors. The best detector that was used for the big gold was probably the SD2000, which came out with really big coils, and it's pretty standard. There's lots of big gold coming out, and as the detectors have turned into more and more fly spec specific detectors, you don't see the big gold as much. Still there. I know some spots. I know there's big gold there. I know there is. I just got to go and gear up and go and do it. Done some research, and I think next time I go out, I'll have a good chance of pulling a really big one. As big as my hand, I'd say, or around about that size. So see how that goes. Anyway, I'm going to go and do a drive. Catches.